Hello and welcome back. If you follow the channel, then you know that my friend Dan brought over this vintage mystery homebrew computer that had a note stuck to it that says TRS-80. Dan bought this computer at an amateur radio festival in upstate New York, and the lady who sold it said her dad built it sometime in the late 70s. She sold us the entire computer with some extra cards and some wire for a mere $20. In the first episode, we took an inventory of what this computer really was. We opened it up and peeked inside, found a massive power supply, we found a CPU board, a video board, and a mystery add-on card. Now I must say thank you to everybody for the outstandingly positive response I received on that video on YouTube and other social media channels. Really been very delightful to me to see that many of you are interested in what happens to this computer and see whether or not we can resurrect it. I also received many helpful hints and feedback. So we are learning as we're going here, and any helpful hints are truly appreciated. Now, some people have doubted based on the first video whether or not this truly is a TRS-80 because there are too many chips on it. When other people said that maybe it's a TRS-80 because sometime in the early 80s, there were a bunch of homebrew enthusiasts that were trying to implement an S100 bus on the TRS-80 architecture. On the other hand, another person pointed out helpfully that the add-on card, at least in part, might be a floppy controller because of the 1771 chip that's on there, which I didn't notice at the time when I was making the video. And moving forward, we are going to shed some light onto the architecture of this homebrew computer. We'll see if really the CPU board and video card and such implement the TRS-80 architecture. We'll see if the backplane implements something S100D or maybe it's some own homebrew bus. So we will slowly dive into the individual components of this computer and see if we can bring it back to life. It'll be a long road until we can safely fire some electrons at this computer. But first things first, we have to make sure the power supply is in fact okay. We have to find out what kind of voltage rails we are working with here, whether or not anything is missing, whether or not anything is broken, whether or not the capacitors held up, and see if we can at least get some stable power output with a minimum load or something out of this computer. We'll start with that, and stay tuned. Okay, welcome back, friends. One thing that we've already done, other than remove the cards, we have made some room in the power supply section. My friend Dan is coming over a little bit later, and what we want to do is see if we can revive this power supply and see if there are any stable voltages in there. So in order to do that, we took a bunch of pictures on how all this is hooked up, and I specifically disconnected here the bus, the where the actual electronics live, from what I believe to be the voltage rails over here. So yeah, just to be able to get access to this and then later be able to probe it. For now, what I want to make sure is just take a brief, quick inventory of what these components are. I mean, obviously transformer, bunch of capacitors and such. Take a brief inventory and then see if these capacitors here are shorted or if they need some help. Yeah, okay, so we got some labels here. +5, +5, good. So the green wires coming off of the bus, so these green ones here are +5 then. There's at least two +5. Any other labels? Can't see them without... Oh, white must be ground. Purple is +12, it seems. And what's the other one? I cannot see. I would bet the other one is probably -5 volt rail. Transformers over there. Let's do some probing, shall we? To see if we have anything that is shorted. So let's see here. There you go. There we go. Yep. I guess there's 3 different 5-volt rails. I'm guessing one of them is probably a minus 5-volt rail. 2 voltage regulators, and when I probe, yep, this one here is a variable regulator, and the other one down there is not. So I'm not sure about the capacitors here, but you know, it's from the 70s, so maybe the capacitor plague hasn't struck yet. This one isn't short, that's good. This one, though, is. Oh, yeah. It might be shorted through the transformer, actually, now that I'm thinking about it. So let's get these capacitors here out and see if they hold a charge. Oh, there's these convenient quick releases there. That's nice. $7,400 microfarad, 35-volt DC. $1,000 microfarad, 30-volt DC, 45-volt switch. Also general electric. Right? To the bench supply we go. We are on the bench with our 2 capacitors, and we want to see if they are in fact dead or if they're still hold a charge. They still have any capacitance left in them. Or as curious Mark would say, if they're still in fact capacitors. So let's get our instrumentation going. We're going to avail ourselves of our bench supply, currently set to 1.5 volts. Let's set that all the way to 0. Before we do that, we want to be sure we draw at least a little bit of current. Yeah, like 3 volts is good, and then we set the current limiting mode to half an amp. No, let's do like 100 milliamp or so. Yeah, that's good. All right, that's it. So now the power bench supply is in current limiting mode, which means it will not put any more current than that in here. So we're going to slowly increase the voltage here. What we should see is that this capacitor, as it charges up, is going to draw a little bit of power, and it's not going to draw more than 100 milliamps or so. And when I'm satisfied that it's not going to start smoking or bubbling or doing weird things, we're going to see if we're going to we can increase the capacity, the current a little bit, maybe to like an amp or so, at most, maybe an amp and a half, and we'll slowly increase the voltage here to its rated maximum, which for this guy here is 30 volts DC. So I'm going to keep it at like 28 volts. We'll see how it goes. All right, so that being said, let's just get going here. Let's increase very slowly first. Okay, we can see there's some voltage going in, and we saw how the power was going up a little bit. Yep, but the one thing we don't want to see, of course, is this thing starts smoking or bubbling. And what we don't want to see is that we are punching in voltage and it draws current and that there's a consistent power draw. So we want these numbers to come up and then come back down again. And that is an indication that this is now sufficiently charged. So let's do 1 volt. Yep, see, it went up a little bit. 1.6. Yeah, it seems about right. Yep, okay. That's maybe to 5 volts or so. Slowly. Yeah, it's drawing like 30 milliwatts at most. Okay, let's increase the, the current a little bit. It's not drawing much. Okay, that's good. It decreases again. Let's see what it does, and it slowly decreases equivalently with the decrease of the power supply. Take that out, power supply decreases, and the capacitor still holds a charge. That's pretty nice. And also I want to make sure that the current limiting is Like 1 amp, okay. So let's get some. Yeah, see, the capacitor still has. Now the capacitor is feeding the power supply. See that? Because it was set to 0, and now the capacitor is draining through the power supply. That's kind of cool. All right, let's bring her up again. That's maybe to 5 volts or so. Now we set the current limiting to 1 amp. And yeah, it's going okay. Maybe go to 10 volts and see if it holds a charge at 10 volts. Oh yeah. It's dropping a lot quicker now, but that's actually okay. That's not too bad. It definitely holds a charge at 10 volts. All right, let's keep it going again. So I think, yeah, this capacitor will learn to be a good capacitor again. This capacitor is fine, I'm wagering to say. Let's drain it though. Ooh. Yeah, that's how you ruin your stuff. Let's get ready for the other capacitor. Okay, we're good. I think I'm just gonna leave it at the 1 amp current limiting, and let's get after it. And we're draining it. Now we're draining the capacitor through the bleed resistor in there. Nice. This guy's okay too.
Yeah, I can try not to get in front of it, but I'm going to.
No, it's all right. Like, do you want to say hi to the camera, Dan? Just in case I'm going to edit it out, but just in case I'm not. Hi, this is Dan.
Hello.
Dan, my very good friend. Dan and I have been friends for 20 years, my dude. We've been friends.
It is true.
Now we work together, and we restore old computers. So all boards have been removed. Some info to come on what we found out about these here chips. But we are satisfied that we disconnected the bus bar here, the voltage rails that go straight into the back pane. We disconnected those from what we believe to be a regular power supply, a linear power supply. And we have reason to believe that this might just work. So maybe not. Let's get the entire thing in the shot. Just in case, let's get the entire thing in the shot, including, I guess, the place we're going to plug it in. Okay, so you ready, sir?
Yeah, it should be off, so.
It should, well, right. Nothing blew up yet.
No drama.
Okay, no drama yet. You ready?
Yeah.
1, 2, 3. I don't know if that's on or not.
I think it is.
I think so too. Measure something.
Yeah.
What should go measure the input on the caps first, I guess?
Sure. I can do that.
What we got there?
18 volts.
18 volts. Negative 18. No, 18 volts.
Yeah.
Okay. 18 volts there, and we got 18 volts in that one too.
Good.
Okay, good. We kind of expected that, right? And then we have 2 linear supplies, 2 linear regulators there, one adjustable, one 5 volt. And Dan is now going to see if he can probe.
What do we got there?
-5, my dude. You were
I'm
right.
I'm probably back. Yeah, no, I'm actually, it's hard to tell.
You might not be, actually. You might be right. We got 5 volts on there.
That's +5?
Yep, that's plus 5.1 volts, and that's the one of the green wires, right?
That was, yeah. What do you got here?
It jumps around. We got 4.5. Ooh, don't do that.
Just trying to get it through the corrosion, you know?
Yeah, I understand.
What do you
Okay, we got 5.09. That's pretty good.
This one should be our 12 volt, I think.
You got that one right. 12.3.
Okay.
Wow, I'm surprised.
So back on this first one though, that one.
Yeah,
Let me check this one again.
that's the one with the brown and white.
Yeah.
So it jumps a bit. Negative 4.8. It's settling at. So you were right. The peculiar thing about this design is that there's a transformer underneath this board, and then there's a transformer on top of this board, and this output goes straight to the bus bar, but the big transformer underneath, I'm guessing, feeds the two regulators to generate the 5-volt rail.
I think the
12-volt rail.
bottom one is probably center tapped, and so that and they're just treating it as two supplies.
I see.
Two 5-volt supplies, and then
Except one of them is like, what's the polarity?
yeah, they were the same.
Okay.
The only I think.
Then what?
You have
I'm
to
wondering
tell me,
if he's actually just hooking up the two wires reverse,
right,
and is making that the -5 rail.
Is this plus or 5?
We got plus 4.9-ish, not 5-ish. Yeah, let's call it 5 volts with the corrosion and everything.
And this one?
Now you got 5.1.
Yeah, so that's just the two rails. Okay.
All right. Well, I'm guessing the way to find that out is if you measure the green one, right, and then which one, and then between one of the two, we should have a potential of like up to 10 volts if the other one is negative, right?
Oh, like from green to green.
Yeah.
Yeah, but I think they're both positive. Should be zero-ish.
You found nothing? Yep, 0.
But then from this guy, this is on the brown and whatever one.
Yep.
We should have 10.
You got 0.13.
Okay. That's
Interesting. So we got, those are two 5-volt rails for some reason.
good. Yeah, but they probably are not. They're through something.
You know, I'm wondering if he separated the two 5-volt rails for the one of them to supply the like a cassette or floppy or something like this, so you won't have ripple from the spinning motor.
Could be. Could be. I've also seen things where like memory has its own
5-volt supply.
Yeah, but I'm not sure that's. I don't think that would be the case here. Not sure.
Me neither. I'm thinking, like, I mean, the TRS-80 schematics, they just, assuming that, well, let's turn it off. It doesn't have to keep on. TRS-80 schematics, they don't differentiate between the two 5-volt supply.
I don't think so. Not obviously on this complex.
Except in this one instance, and I'm pretty sure that's a typo, like where there was a plus missing.
Oh yeah, that's right.
Yeah. All right. Well, power supply works.
Yeah.
I guess. All right. Yeah. So when we flick the switch here in the back of the unit, we should now see 5 volts there, and we should see some kind of signal on the scope, unless I blow up my scope, in which case that's sad. 5 volts up, and it immediately shoots up to 5 volts. Good. So let me just quickly get set up here. All right, here we go. And now I have to go to channel and do AC coupling. You can see when I speak, he's maybe too faint on the camera, but yeah, that right there is our signal, our ripple signal, and that's a smooth as heck signal, my friends. Check this out. So there's every once in a while you see how there's like noise, these spikes here. That's just the regular buzzing that's on the that's on my power line. And look at this. We're when I'm being quiet, it's hovering around 55 or so hertz. We could measure it. Let's get the cursor going here. Cursor on.
we want to do manual cursors, please. All right, zoom in a bit. Yeah, there we go. And now what we're gonna do is we're gonna move the one cursor. What is it, cursor A or cursor B? Yep, from here to here. That is the difference between the two of them is 8.6 microseconds. Let's move the probe over to the 12-volt rail like this. Single shot it so we can measure. I can also turn off the power supply now. So this is the 12-volt signal. We want to move the cursors. (130 millivolt peak-to-peak ripple, 40 microseconds. Cool. That's an okay amount of ripple. Boy, I can't tell you how happy it makes me to know that the power supply is working. I mean, an option would always be to just rip everything out and then replace with modern components, right? But I'm fascinated by this piece of art, so I kind of want to keep this as OG as possible.
I guess now the next step would be to validate the architecture of the CPU board enough to see what part of the Z80 architecture, if any, it's implementing. One of the things we already found out is that the Z80 takes, what is it called, 2102 memory? 8 chips to be exact, and they are here. We found them. They are right there. I thought this was the memory here in the first video, because there's some K1X58F mystery chips on
I
there.
think it's KIX, not sure.
You think it's KIX?
I think so.
Oh, man. Anyways, one of these contains the RAM, and it could be this one. It could be that one. Who knows? Anyways, thanks for watching.